Hi everyone, this is Miss Afric here, and this is your Chapter 13, Day 4 video, where we're going to talk about how to find the reference angle for a given angle theta. Alright, to start out, we're going to go ahead and define what a reference angle even is. So let's let theta prime be the reference angle of theta. And just so we know that this part right here, that theta with a little dash above it, we read that as theta prime. Just so you know what you're reading when they ask you for that in the problems we're going to be doing later. Okay, so it says let theta prime be the reference angle of theta. And a reference angle is the acute angle, the acute angle from the terminal side of theta to the x-axis. Okay, so it's the acute angle that's formed by the terminal side of our angle theta to the x-axis. And I'm going to show you kind of some examples of what that might look like. In general, there are 4 different quadrants that an angle could be in. It could be in quadrant 1, quadrant 2, quadrant 3, or quadrant 4. And each one, it's just slightly different about how you would find that reference angle. So I'm going to go ahead and show you just kind of a quick sketch with an angle in each quadrant so we can kind of take a look at where that reference angle would be. Okay, so let's say we are starting with an angle that had its terminal side in quadrant 1. Well, remember, to find the reference angle is going to be the acute angle from the terminal side of theta to the x-axis. So from the terminal side right here, and it's the acute angle to the x-axis. So in these kinds of problems where the terminal side lies in quadrant 1, our reference angle, theta prime, is actually just that acute angle right there, from the x-axis to the terminal side. So that's where our theta prime would look like. Let's try an example now in quadrant 2. So let's say we had this angle in quadrant 2. Well, once again, our reference angle is the acute angle from the terminal side of theta to the x-axis. So the acute angle that's formed by the terminal side of theta and the x-axis is this angle right here. So that would be our theta prime. So you can kind of see how depending on where the quadrant is, where the angle is in which quadrant, you can kind of see how the reference angle, it changes how you're going to find it. So let's try one if it's in a quadrant 3. So quadrant 3 will be right down here. So let's say this is our angle theta. Well, if that's our angle theta, again, reference angle, it's the acute angle from the terminal side to the x-axis. So that's going to be this angle right here, and that's going to represent our reference angle, or theta prime. Remember that our reference angle should be an acute angle. So acute angle, just to remind you, means it should be less than 90 degrees. So you know that something went wrong if your reference angle is bigger than 90 degrees, because our reference angle should always be acute. Alright, the last little one here, let's check an angle in quadrant 4, which is right here. So say I had this angle as my theta. Well, once again, our reference angle is from the terminal side to the x-axis. So that's this angle right here, so we would call that our theta prime. And we're going to be able to find these theta primes relatively easy just by taking whatever our x-axis angle is and subtracting the terminal side, or the original angle theta. So let's try some examples. Alright, example 1, it says find the reference angle theta prime for each angle theta. Whenever you're trying to find the reference angle, first thing you always want to do is sketch the graph of theta, or sketch the angle theta, because you need to see where theta is so that you can recognize what theta prime will be. So first step in part A, I'm going to go ahead and sketch my angle theta. Notice how theta is positive, so I know I'm going to be moving up because it's a positive angle. And notice how it's in degrees, so I want to work with degrees. So I'm going to go ahead and label the 4 or the four most important angles that we see: 0, 90, 180, and 270 degrees. And then if we go all the way around, we end up back at 360 degrees. And we can see, okay, 140 degrees, that's going to be between 90 and 80. So I'm going to go ahead and draw my initial side and then my terminal side. And this is my angle theta at 140 degrees. So to find the reference angle, well, here's our terminal side, and here's the x-axis. Notice how the part of the x-axis that we're using is the 180 degrees part. So our theta prime here is the angle between 140 degrees and 180 degrees. So to get that theta prime, all I'm going to do is do 180 minus 140. All right, I'm just trying to get that angle that's in between these two. So theta prime here is just going to be 40 degrees. So after you sketch that angle, you should be able to tell how you're going to be able to find theta prime. And that's just your second step. It's just find the reference angle. Alright, let's try another example. Part B. Once again, the first thing you want to do is sketch your angle. And notice how theta in this problem, not only is it negative, but it's also in radians. So a couple different things to make sure you remember when we're labeling these axes. If it's negative, that means we're going to be moving down. And if it's in radians, we want to make sure we use radians to label our axes. Now I'm going to start at 0 radians. I'm moving down because it's negative. Remember that this is negative pi over 2 then, because 90 degrees, every time you move 90 degrees in radians, it's like moving pi over 2 radians. So this is negative pi over 2, but I do want to make sure that I maintain the same denominator so I can recognize where this angle is located. So I'm going to go ahead and actually label this as negative 2 pi over 4 radians. But notice how that's the exact same thing as negative pi over 2. I just rewrote it so that it had the same denominator. So that's negative 2 pi over 4. If I keep going, this is supposed to be negative pi. Well, I can rewrite that with a denominator of 4 by writing negative 4 pi over 4. And I could keep going and labeling it, but right away, let me erase this so we can see it. Right away you can see negative 3 pi over 4, well that's going to be between negative 2 pi over 4 and negative 4 pi over 4. So I can sketch this angle right now. Got my initial side, and this angle is going to be right in the middle of negative 2 pi and negative 4 pi. I'm moving in the negative direction, so that's down. So this angle right here is negative 3 pi over 4. So to get our reference angle, take the terminal side and look at where the x-axis is. So this angle right here is going to be theta prime. That means you need to know what the angle is to go from negative 3 pi over 4 to negative 4 pi over 4. And the difference between those two angles is just going to be pi over 4. Some of you might think that it looks like it should be negative pi over 4 because we are moving in the negative direction, and you're correct that this angle from here to here is technically a negative pi over 4. But when we talk about reference angles, we're never going to be using a negative number for our reference angle because we just want it to be a general positive acute angle. So we're just going to stick with theta prime equals pi over 4. Alright, we've got two more examples. Let's go ahead and try example 2a. Once again, these are just saying to find the reference angle theta prime for each angle theta. So my first step is to sketch my angle theta. Right here I have negative 250 degrees, so I'm moving in the negative direction. So 0, negative 90 degrees, negative 180 degrees, negative 270 degrees. And I can see right away negative 250 is going to lie between negative 180 and negative 270. So I'm going to go ahead and sketch that angle out. Negative 250, it looks like it would be right around there. So this right here is my angle theta. So to find my reference angle, I want to look at the terminal side and then the angle it forms, the acute angle it forms with the x-axis. So theta prime is going to be right here. Well, if this angle is 250 and this angle is 180, I need to find the difference between those. So in order to find my theta prime, I'm going to do 250 minus 180. And that's going to give me a reference angle here of 70 degrees. Alright, one more example. Let's go ahead and try it together since it's in radians, just to make sure we fully understand those radians. We have 8 pi over 3. Okay, that's a positive 8 pi over 3, so we're moving in the positive direction. I'm going to go ahead and label my axes. Once again, you want those denominators to match. So if I start at 0 radians, the easiest way that I find to do it is to do pi first, because pi should be the easier one to write. If we want the denominator to be 3, then pi is the same thing as 3 pi over 3. And then this angle right here is halfway between 0 pi over 3, and 3 pi over 3. Halfway between that is going to be 1.5 pi over 3. So that means every 90 degrees I move, I'm moving 1.5 pi over 3. So I go from 0 to 1.5 pi over 3 to 3 pi over 3, and then I add another 1.5 pi to get 4.5 pi over 3. And then to come full circle and get that 2 pi, this is also known as 6 pi over 3. But now you can see, well, going around the circle once doesn't quite cut it in terms of sketching out our angle, because our angle is bigger than just one circle. So we're going to have to keep going and labeling it. If this is 6 pi over 3, if we add another pi over 2, that's really the same thing as adding 1.5 pi over 3. So this is also 7.5 pi over 3. And you can see we're getting close, so let's do one more. Add another 1.5 pi over 3, and we end up at 9 pi over 3. And now it's very clear that 8 pi over 3 is between 7 pi over 3 and 9 pi over 3, which makes it in quadrant 2. So I'm going to go ahead and sketch that angle. Initial side, angle 8 pi over 3 is somewhere right there. And remember, we went around the circle once, so this angle is actually this angle right here. But the fact that we went around the circle once actually doesn't really affect our reference angle, because in the end our reference angle is the angle from our terminal side to the x-axis. So we don't care how many times we go around the circle, all we care about is where that terminal side ends. So just a reminder, this is the angle 8 pi over 3. So our theta prime here is going to be the difference between 8 pi over 3 and 9 pi over 3. Hopefully it's clear that that difference is just a pi over 3. So our reference angle here is pi over 3. Okay, I hope you've understood all these examples. If you still feel a little confused, make sure you rewatch any part that might help you, or go back and try some examples on your own to make sure you're doing it correctly. In class, we'll be doing some more practice, and hopefully we'll really get a good understanding of this by the end of class. Thanks so much. See you soon.